solving quadratic equations by completing the square. Last lesson we learned how to complete the square for a quadratic expression. Now we're just adding the requirement of solving the square for a completing the square for a quadratic equation that equals 0, and thus getting a solution. So it's really only a very small extra concept, just combining solving, which you know how to do, and completing the square, which you now know how to do. So just 2 examples, and I'll do another example in another video if you need it. So solve this using completing the square. So we want to complete the square. I want b over 2 all squared, which will mean I've got negative 4 on 2 squared, which is going to give me 2, because that's it's going to give me 4. Sorry. Negative 2 squared is 4. My bad. Add and subtract 4 in the middle here, so that I'm completing the perfect square for x squared minus 4x plus 4 minus 4 gets put in here, plus 2 equals 0. And I'm going to complete the square so that I have this as a perfect square. The number that was in my brackets was negative 2, so factorising this is going to be x minus 2 all squared. Minus 4 plus 2 means negative 2, or minus 2, equals 0. I've got a difference of perfect squares. This isn't a plus, so I can solve this. We factorise it as a difference of perfect squares, so of course this is x minus 2 and squaring that, we want this to be minus root 2 squared equals 0. First term, x minus 2, second term is root 2, and I've got a plus on my first bracket. First term, x minus 2, second term is root 2, and I've got a minus. That equals 0. I really should have given myself a stack of extra space here. Sorry about that. So, therefore, x minus 2 plus root 2 equals 0. This one equals 0. Or x minus 2 minus root 2 equals 0. We have to solve both those in terms of x. So the top one, x equals, add 2, subtract root 2, 2 minus root 2, or x equals, add 2 and add root 2, 2 plus root 2. So I've got the 2 possible solutions for x. So we got to that point when we learned how to complete the square. We're completing the square for an equation that equals 0, and using the null factor law, this bracket equals 0, or this bracket equals 0, this expression or that expression, and rearranging so it's in terms of what x could be. Now, having used up all that space, I'll have to skip a few pages. Oops. And we were about to also do x squared plus 6x minus 11 equals 0, just so we've got a second solution. Now, if you don't think you need to run through this again, no worries. The difference is that we can simplify the surd that we get here. So we complete the square. It's going to be 6 over 2 squared, which is 3 squared, which is 9. Adding 9 in here, so I've got x squared plus 6x plus 9 will be a perfect square. Then, of course, minus 9 to cancel that out, minus 11 equals 0. Factorize this. We know it will be the number that was inside the brackets. So this is x plus 3 squared minus 20 equals 0. Now I have a difference of perfect squares. I'm going to rewrite 20 as... Now you could skip this line here if you want. I normally put it in because it helps me think in terms of what is this term here. X plus 3 squared minus root 20 squared equals 0. It is an optional line. Factorize as a difference of perfect squares. X plus 3 is our first term. Now, root 20 can be simplified to 2 root 5. So I'll have plus 2 root 5, x plus 3, my first term, minus 2 root 5. So of course if we have a certain it can be simplified, we do. Then I've factorized. I need to use my null factor law. X plus 3 plus 2 root 5 equals 0, or x plus 3 minus 2 root 5 equals 0. Rearrange so we're in terms of x. X equals negative 3 minus 2 root 5, or x equals negative 3 plus 2 root 5. Or of course you could give your solution as x equals, oops, that's a 3, sorry, negative 3 plus or minus 2 root 5. So you can give your solution as there's two possible versions of x with your plus minus, or you can give them separately. I'll do another video with an example with fractions in case anyone would like it.